Assalamualaikum and good day. We are continue again with reinforced concrete foundation design for CMA 422. Let's proceed with the next example, which is example number 2. A column 450 times 450, which is this one is the column width, carries a dead load of 800 kilonewton, which is GK, and 400 kilonewton for the imposed load QK. The safe bearing pressure is 200. This one is PB. Design a square base to resist the load. The concrete grade is 30/5, which is this is FCU, and reinforcement grade is 460, which is FY. The condition exposure is moderate for non-aggressive soil. The nominal cover is 40 mm for concrete cast against blinding, which means this is the value of concrete cover. Right, so here the question did not mention about the height of the footing, and it also did not mention anything about the self-weight and the diameter of the reinforcement. Therefore, we have to make some assumptions, and kita boleh check on the assumptions whether assumption kita okay atau tidak. Right, so first of all, we need to assume the footing weight since kita nak kira the serviceability load to design for the footing tu berapa besar size dia. We have to assume. So this one is assume. I assume 80 kilonewton first and kita akan check So for serviceability load, then I just use the 1.0 GK plus 1.0 QK plus 1.0 W, and I have all this value daripada soalan, and this one is based on my assumption. Then I get 1,280 kilonewton. Next, we're going to calculate the size of base, which we know that to get that is by dividing the serviceability load with the bearing capacity of the soil, or PB. So PB is given, and the serviceability load just take from the calculation above. Here I get 6.4 meter square. Then we need to square root kan 6.4 meter square to get one side berapa besar lah. Since ini adalah square base. When I square root kan 6.4 meter square, I get that it is 2.5298, which is 2.53 meter. So which means that kalau ikut ni 2.53 sebelah and 2.53 sebelah. Macam ni lah. Okay, sebab kita square rootkan dia. So I round it up sebab 2.53 is the minimum value. So kita tak boleh go lower, tak boleh go to 2.5, salah So kita kena naikkan to 2.6 meter. So this is I punya jawapan And we get the new value for area, which is 6.76. Then we need to assume the overall depth of footing, or H. This one also not given, assume also. Right. So daripada assumption ni kita boleh check whether our assumption is correct or not. Right. So self-weight of the footing equal to area darab dengan H, which means that this two adalah volume, darab dengan the unit weight of concrete, which is standard 24 kilonewton per meter cube. Kena hafal lah. So 6.76 the area, darab saja dengan height yang kita assume tadi, which is 500 mm, tukar jadi 0.5 meter, darab dengan 24 kilonewton per meter cube, dan you dapat 81.12. Okay, so ini sebenarnya cara kita checking. So kita 81.12, our answer here, this value must be lower than what we assume di atas ini. Right? So kalau awak dapat lebih besar, maksudnya tak okay. Right? Sebab our assumption tak cukup. Kena go higher Therefore, kita kena assume new value. Okay, sebenarnya kita nak turunkan value inilah ataupun kita naikkan value ini. Itu adalah salah satu pilihan. Kalau nak turunkan, mungkin you boleh turunkan dekat H. So, kalau kita turunkan value of H, contohnya kita letak 400 mm, mungkin value ini akan turun. kan, which is kalau 6.76 darab 0.4 darab dengan 24, you akan dapat 64.896, which is, it is lower than 80 kilonewton. Okay, however, if you still remember that kita ada buat preliminary checking for shear. Okay, so sometimes mungkin kalau kita punya footing, the depth is terlampau rendah, okay, kita agak risaulah. Mungkin the preliminary checking for shear tu akan fail. Therefore, I tak nak turunkan dekat the height. So, I choose untuk naikkan value ini. Right, so our assumption kena bertukar lah, tak boleh pakai 80 kilonewton. Kita akan naikkan our assumption, right? So kita naikkan, so I reassume balik ke 100 kilonewton. And recalculate again the serviceability load with this new value of footing weight. And then I have to calculate the size of base, but if you notice here, even if you naikkan 100 kilonewton on the serviceability load, bila saya kira, okay, tak lari jauh mana lah kat sini kan. Jadi, lebih baiklah awak tukar assumption on the footing weight. Right. So, kalau saya bagi 1,300 to 200, memang I dapat 6.5 meter tepat-tepat square, and then I square root kan, then I dapat 2.55. So, here, I round it up to 2.6 times 2.6, which is sama macam previous one, 2.6 times 2.6. Okay, tapi okay, overall footing weight, sorry di sini salah, ini adalah 500. So 500 di situ, calculation saya betul Okay, so 6.76 darab 0.5 darab 24, masih lagi 81.12, sama macam sebelum ni. Sebab tak ada apa yang bertukar, kita just tukar hasil footing weight kat sini, tapi the dimension of the footing masih sama. However, bila kita compare dengan assume footing weight kita, which is 100, okay sebab dia lebih kecil, salah di situ, lebih kecil daripada that 100 kilonewton assume. Right, so next, kita akan kira the bending reinforcement since kita dah dapat the dimension of the footing. So, kita nak design untuk steel. Using the ultimate load 1.4 GK plus 1.6 QK, masukkan saja value GK and QK inside the formula. Then I get 1,760. And as usual, I need to calculate for the ultimate earth pressure, PS. Okay, so which is the ultimate load bahagi dengan area of base, then I get 260.355 kilonewton per meter square. Right, so I need to calculate the moment at YY. Where is YY? Here is YY. Right, so bila saya kira 1075 ni saya dapat dari 2.6 meter minus 0.45 bagi 2. So inilah dia. Because you nak dapatkan moment daripada the centroid here. Pergi ke YY. So separuh daripada that 1075 ni lah. 1075, ini 1075 bahagi dengan 2 ini sebenarnya So saya dapat 391.135 kilonewton meter. Okay, and also need to remind, sini jangan lupa ini adalah column width bukan concrete cover. Because our column width is 450 mm. Jadi 0.45 meter. Right, so we need to calculate the preliminary check for shear. So as I mentioned, that's why I tak nak turunkan kalau boleh on the total height kan, here. Because 500 ni is the based on our assumption earlier. Yang kita assume masa kita kira for the footing di sini. Ni jadi you have to stick with that value So 500 minus 16 mm, ini our assumption, ini I assume. Okay, sebab kalau kita assume, kita choose to the bar size yang smaller sebab we going to use number of bar yang banyak. Okay, bukan macam kita buat untuk beam ataupun untuk column, tak perlu banyak-banyak sangat bar. Tapi kalau untuk footing, sebab footing ni besar, therefore we might use quite numbers of bar. Therefore kita akan ambil size yang kecil lah. Height minus dengan the diameter of main reinforcement minus dengan 40 mm the concrete cover. Dan dapat 444. Right, so from that kita nak check with the formula of D equal to 8 square root kan the ultimate load. So ultimate load kita kira 1760 previously di sini. Square root kan darab dengan 8 dan you dapat 335.619 mm which is lower than the effective depth yang kita kira di sini. Okay, so mesti dia lebih rendah That's why kalau boleh tadi height ni kita jangan turunkan. It's just that mungkin kita risaulah takut preliminary check for sure ini fail lah. Kalau kita pakai the the total height yang sangat rendah Right. So from that kita dah ada MYY and we already check for the shear preliminary checking saja. Right. We going to calculate for K untuk dapatkan AS, Z dan AS. See, okay, so for K, M is MYY, masukkan saja value MYY as usual 35 dari soalan, 2600 yang kita dah design daripada size of base tadi and the effective depth yang kita dah kira here. Right, 444. Then, I dapat 0.022. Okay, and masukkan dalam formula Z. I dapat 0.975D which is bigger than 0.95D. Okay, so when it is bigger than 0.95, we know that when we calculate for AS, we're going to use this value untuk masuk dalam formula. Jangan pakai 0.975 pakai 0.95. Masukkan saja. So ingat juga ini adalah MYY. So bagi dengan 0.95 darab dengan FY 460 given the question. Darab dengan Z which is 0.95 darab dengan D. So 0.95 darab 444 mm. Then I get 2121.967. Okay, so after that we need to check about the distribution of reinforcement. Okay, first kita tahu formula of 3C/4 plus 9D/4. Sama saja macam example number 1. So 3 darab dengan C. C di sini adalah column width. Tambah dengan 9D. D is effective depth bahagi dengan 4 Right, so saya dapat 1561.5 mm and we need to compare with the value of LC. What is LC? LC is the length from the center line. Maksudnya separuh daripada inilah berapa LX bahagi dengan 2 So 2600 which is our LX ataupun LY sebab ini hanyalah square column. Okay, bagi 2 so saya dapat 1300 which is this value is less than 3C/4 plus 9D/4 which means that the reinforcement should uniformly distributed. Kalau dia lebih besar then it is like the other case yang saya pernah explain in example number 1. So bila dia uniformly distributed then kita boleh tengok on the berapa banyak bar that we need, but we need the value of AS. So AS is according to this value lah yang kita dah calculate sebelum ni, 2121.967. Right, so this is the value. Then we need to see lah sebab kita dah assume previously on the bar size sebab masa kita kira effective depth, masa kita kira for preliminary checking for shear tadi, kita dah assume 16 mm. So we have to stick with that. Okay, so 2121 if you look at according to the table, kalau dekat 10 ni pun value dia masih lagi tak capai 2121. Okay, so what we can do, kita boleh kira manually which means that kita kira 11 darab saja dengan kalau satu number of bar dia berapa? 201. Kalau 12 darab dengan 201. Sebab kalau satu bar 201, kalau 11 bar darab dia dengan 11. Kalau 12 bar darab dengan 12. Right, so bila saya kira as I said, kita boleh pakai antara dua ni lah. Okay, this is the nearest, but I'm going to select 12T16. Okay, instead of 11T16 because of the tendency untuk shear failure, punching and transverse to happen when the value of reinforcement yang kita select daripada bar adalah dekat sangat dengan the minimum value of area untuk reinforcement. Okay, so kita tak nak dia lampau dekat sebab ini 2211 dengan 2121 tak jauh. Okay, so kita risau for the shearing to happen. Okay, so I ambil 12T16 and I need to check for the spacing. So for the spacing 2600 if is the LX and LY. Okay, sama saja because this is square footing, so you have to minus with number of bar which is 12 yang kita dah select tadi, darab dengan 16 mm, tolak dengan 2, darab dengan C which is the concrete cover, dua belah kanan dan kiri, bagi dengan number of bar minus 1, so jadi 11 lah. So I dapat 211.636 mm, so kita kena round it down sebab this is the maximum value, lagi rapat lagi bagus spacing tu. So I letak 200, you boleh juga letak 210, tak ada salahnya, jangan lebih daripada value ini. So I put 200 here. So I draw or I sketch for the cross section of the footing. Okay, so ini adalah total height which is according to what I assumed earlier, and ini 2600 yang kita dah dapat masa kita design untuk size of base, and 12T16 is yang kita kira ni lah, dan dia punya spacing 200 both way, maksudnya dia bersilang with each other, right? So we are done with example number 2. Okay, thank you so much and have a nice day.